Okay, so today we're going to be talking about energy transformation. Yesterday we talked about the different forms of energy. So today we're going to learn exactly why it is that you can charge a cell phone. So, how do we have that initial form of energy change into something that's a lot more useful? So, the focus question that you should be able to answer by the end of the day is, how does your cell phone get charged? So, we're going to quickly go through and review the different forms of energy, which are chemical, electrical, light, mechanical, nuclear, thermal, and sound. You'll have an opportunity to jot down a lot more of the definitions that some of you guys didn't get to do yesterday. So, quick review of chemical energy. Chemical energy is energy that's stored in the bonds of atoms. I have these pictures here because whenever you see these things, this is exactly what you need to think of. Any food is chemical energy, batteries are gasoline for your car. Electrical energy is the energy created by the flow of charged particles through a conductor. So basically, moving electrons is what creates electrical energy. Light energy, also known as radiant energy, is energy in the form of visible electromagnetic radiation. Nuclear energy is the energy that's stored in the nucleus of an atom. Very, very explosive. So when that nucleus splits, it releases that energy. Thermal energy is the energy in the form of heat. So that's what you feel from a fire very often, yes. Okay, sound energy is energy that's in the form of audible vibrations. So basically, vibrations that you can hear. Mechanical energy is the sum of kinetic and potential energy in an object. This one's a little weird. Usually, in most of the examples, mechanical energy will look most like kinetic energy. So any object that's moving or has motion, if we're talking about a specific form of energy, is going to be mechanical energy. And then, of course, the overall types of energy that all of these subcategories of energy fall under are both kinetic and potential. So, kinetic energy is the energy of motion, and potential energy is stored energy or energy that's available to do work when necessary. Okay, so again, we're going to be talking through, how do we charge our phone battery? How do we take that initial form of energy, which is electrical, and turn it into something that's more useful for us? The way that we're able to do this, please copy this in your notes, the second bullet point, is by what we call energy transformation. And so when you think of transformation, I think of the word transformers. And if you think of that example, they start off as cars and they change into these Autobots, or things that can essentially fight off other things. But transformation is something that changes from one thing to another. So energy transformed from one thing to another. All energy transformation requires an input and output, kind of like a chemical reaction. So there's an energy that goes in and there's a type of energy that comes out. So second bullet point that you're copying, energy transformations are, represented. Energy transformations represent a change in energy from an object's input energy to an object's output energy. So ignore the word R. Why is this? Because of what we call the law of conservation of energy. This should sound somewhat familiar because we just talked about the law of conservation of mass, which stated that atoms could not be created. Basically, the same amount of atoms that you start off with in the beginning are going to be the same amount of atoms that you have at the end. And we know atoms is what gives an object its mass. So mass at the beginning of a chemical reaction is going to equal the mass at the end of a chemical reaction. So basically, nothing's lost. It's the same idea here. Energy is never lost. Energy cannot be created or destroyed. However, it can change forms to different types, or it can be transferred from one object to another. So let's look at an example of a transformation. When wood burns in a fire, wood burning is chemical energy that is, Oh, I apologize. This is a mistake. Chemical energy is locked inside of the atoms of the wood. Once it is burned, it releases thermal energy, and from that light energy and some sound. So I apologize because here I say that thermal energy is the input energy, and that's actually not correct. Chemical energy is the input energy. The output energy is actually thermal and light. So here's another example. Solar panels, which we talk a little bit more about tomorrow when we talk about renewable and non-renewable forms of energy. Solar energy captures the sun's light and turns it into useful electrical energy for us. So the input energy is light energy, and the useful energy form is electrical energy that we use to make all of the objects in our house run. So again, take a second to review. Again, all of these forms of energy fall either under kinetic, potential, or in the case of mechanical energy, both. So it's important to understand this before we get into some other examples. Is I like to think of kinetic and potential as the mother and father energy, and the different forms of energy as the children. When you transform energies, you can only go from child to child or parent to parent. So for example, I can transform from kinetic to potential energy or potential to kinetic energy. Or I can transform from electrical to sound or electrical to or chemical to electrical. However, I cannot transform from kinetic to sound or from potential to chemical. So as we go through the examples, you have some boxes on your paper. You guys are going to keep track of the energy chains. You're going to label what is your input energy and what is your output energy, and then we'll fill in those energies in between. So let's look at the first example, a ball rolling down a hill. So at the top of this hill, the ball is still, it has potential to move. So we say that the ball's input energy is potential energy, but as it rolls down the hill, it transforms from potential energy to kinetic energy. Okay, another example. So when we're thinking about the transformation here, I like to think, what makes this object work? And we know that we have to plug a light in order for it to work. So the input energy that the light is getting is electrical. However, when I think of the output energy, I think, what is the purpose of this object? We turn on the light bulb so that we can see. So the output energy that's useful for us is light. So again, electricity is the input, light is the output. However, there is something else that's created, although not intentionally. If you ever put your hand next to a light bulb, you're going to feel heat. So heat energy is also produced from electrical energy. Now, the reason that heat energy is not on the other side of light energy is because we don't turn on a light bulb to get hot. The purpose of turning on a light bulb is so that we can see. So that output or purposeful energy is the last thing that we see, or that's the last thing that we put in our chain. Okay? An electrical oven, again, I think of what makes it work. Have to plug it in. What do I want to do with it? I want to cook food. I use heat to cook food. So my input energy is electrical. My output energy, in this case, is now heat. Now, the reason that my oven can heat is because there's these coils in the inside that light up. So the electricity also produces light, but again, the output energy is heat because that is the purpose of our electrical oven, so that we can use the heat to cook the food. Okay, and final example, a battery-powered flashlight. So what does it take to make this flashlight work? Obviously a battery. And as we talked about earlier, whenever you see a battery, you should automatically think chemical energy. And the purpose of a flashlight is so that we can see. So we know the output energy is going to be light energy. But let's think about what's happening in between there. So chemical energy is our input energy, light is our output. However, the chemical energy in the battery is converted to electrical because there's some coils involved and things like that. Also, if we turn on the light for a while and put our hand over it, we're also going to feel some heat. Excuse me. But remember, the purpose of turning on a flashlight light is not so that we can get warm, it's so that we can see. So those other alternative forms go in the middle of our chain. Okay. Now it's time for you to practice. Think about the input and output energy that's required to make an iPod work. If you said chemical energy is the input, sound is the output, you're correct. Again, much like a flashlight, there's some electrical components there. That chemical energy is also converted to electrical, and then heat will always be a byproduct. A plant during photosynthesis. Oh, I apologize. This example is not supposed to be there, so ignore that. A television set. I want you to think of the input. What does it take to make it work? What comes out? If you said electricity is the input, the output is sound and light. These are both the useful energies because the TV is not useful if you don't hear it. And also, the light component is what actually produces the picture. But again, if you put your hand behind a TV, it will be warm. So heat is also a byproduct of this transformation. And finally, a cell phone. Okay. Cell phones need a battery to work. That's chemical energy. Transform to electrical. The output, of course, sound and light from the screen. But also, we know cell phones can get warm. So heat is also produced. And that's it. So go ahead, if time permits, go ahead and finish your independent practice and then move on to your exit ticket.